Welcome to day 50 of our low-level design course. Today we will be focusing on one of the most crucial aspects of system design, creating class diagrams and interfaces. These are the blueprints of our software systems. By designing them correctly, we ensure that our code is well organized, scalable, and easy to maintain. In this session, we will discuss how to translate high-level design concepts into detailed, concrete components using class diagrams and interfaces. By the end of today's session, you will be comfortable with creating class diagrams and interfaces that are critical in laying out a clear, structured, and maintainable design. Our goal is to give you the tools to model real world systems effectively so you can break down requirements and translate them into classes, relationships, and behaviors that will make your code modular, testable, and scalable. Let's start by understanding what a class diagram is. A class diagram is a type of UML diagram that provides a blueprint for the structure of a system. It visually represents the classes and their relationships with one another. Each class contains key elements, attributes, methods, and the visibility of these components, whether they are public, private, or protected. Class diagrams give us a clear understanding of how classes should interact with each other and what data and behavior they should encapsulate. Class diagrams play a vital role in software development lifecycle. They help developers and designers communicate how the system is organized and how components interact with each other. In addition to aiding communication, class diagrams improve system maintainability. As the system grows, a well-designed class diagram helps provide confusion by keeping track of which components depend on each other and how changes in one class might affect others. It also makes it easier to scale the system and make adjustments as requirements evolve. Good class design is based on a few fundamental principles. First, each class should have a clear single responsibility. This is the principle of single responsibility, which helps avoid the creation of bloated, complex classes that try to do too much. We should carefully define the responsibilities of each class, ensuring that each one focuses only on one aspect of the system. Additionally, classes should have well-defined relationships with other classes, and those relationships should be clear and meaningful. Finally, the design should favor composition over inheritance where possible, as it results in more flexible, maintainable systems. Interface first design is an approach where we focus on defining the behavior of a system before we even consider the concrete classes. By creating interfaces first, we specify what a component will do, not how it will do. This separation of interface and implementation leads to cleaner, more modular designs. For example, when designing a payment service, instead of immediately jumping to a PayPal payment processor class, we might define an interface like iPayment processor, ensuring the system can easily switch to different payment methods in the future. This approach also helps make the code more testable as we can mock interfaces for unit testing purposes. When designing interfaces, it's crucial to keep them small and focused. The principle of interface segregation encourages us to break down large general interfaces into smaller ones, each representing a specific behavior. For instance, rather than having one large interface for all payment related operations, we might break it into several interfaces such as iPayment processor, iRefund processor, and iTransaction history, each representing a distinct capability. This makes the system more flexible and easier to extend without affecting existing code. Class diagram is made up of several components. Let's go through them. Each class is represented by a rectangle divided into three parts. The top part of the for the class name, the middle part for attributes, and the bottom part for methods. Attributes are the properties of the class, while methods are the actions the class can perform. We also use visibility modifiers like public, private, and protected to control the accessibility of these components. These modifiers help us encapsulate the internal workings of a class, ensuring that its data is accessed in a controlled and predictable manner. Classes don't exist in isolation, they are often related to each other. There are, there are several types of relationships in class diagrams. Association represents a simple relationship where one class uses another. For example, a car class might be associated with an engine class. Aggregation and composition represent hazard relationships. In aggregation, a class can exist independently of its associated class, whereas in composition, the lifecycle of one class is dependent on the other. Finally, inheritance represents an easier relationship. A car class could inherit from a more general vehicle class, meaning a car is a type of vehicle. Let's quickly refresh our memory on UML notations, as they will be essential when reading and creating class diagrams. A solid line with a rectangle at the end represents inheritance, indicating that one class is a subclass of another. A line with an empty diamond represents aggregation, while a line with a filled diamond indicates composition. A dashed arrow represents dependency, meaning one class depends on another class but does not necessarily control or control it. Now let's look at a practical example. Imagine we are designing a payment service. The payment service class interacts with various payment gateways like PayPal or Stripe. Instead of hard-coding the gateway logic, we define an interface, iPayment Gateway, which will be implemented by classes like PayPal Payment Gateway or Stripe Payment Gateway. This allows us to easily switch payment gateways in the future without altering the core business logic in the payment service class. This is a simple but powerful example of interface first design. We define the behavior first and allow for flexibility and extensibility in the system. Let's apply what we have learned with a hands-on example. Imagine we are building an online food ordering system. We begin by identifying the key classes: user, restaurant, menu, order, and so on. Each of these classes will have specific responsibilities and will interact with one another. For instance, the order class will depend on the payment processor interface, allowing us to implement various payment methods. Additionally, we might create an interface like iNotification service to notify users of order updates. The goal is to keep the design modular and flexible so that adding new features in the future will be easier. Let's discuss some common mistakes in class and interface design. First, avoid making your classes too complex. If a class does too much, it's hard to maintain. Instead, keep your classes focused on a single responsibility. Another mistake is to creating too many dependencies between classes. This leads to tightly coupled code, which is difficult to test and extend. Also remember that good design is about flexibility. Don't design your system for today's requirements only, but think about how it might evolve in the future. Now I want you to put your learning into practice. For today's assignment, I would like you to design the class diagram for a small system such as a tic-tac-toe game or a parking lot system. Focus on defining the main classes and their relationships. Also incorporate at least two interfaces such as iPayment processor for the payment gateway or iNotification service for sending messages. Submit your UML diagram along with a brief explanation of your code design choices. This exercise will help reinforce the concepts we have covered today. Let's summarize the key points from today's lessons. Class diagrams and interfaces are foundational elements of low-level design. Good class design starts with clear responsibilities, low coupling, and high information. When designing interfaces, always think about the behavior first. Keep interfaces focused and small. Remember that class diagrams are not just technical documents, they are tools for communication, and they help you ensure your code is organized, scalable, and easy to maintain. Thank you for your attention today. We have covered a lot of ground, from understanding class diagrams and interface design to applying them in real world systems. Keep practicing what you have learned by designing and redefining your own class diagrams. Tomorrow we will continue building on these principles as we move into more complex system designs. Happy coding and see you in the next session.